So on behalf of Hosting Canada, thank you for having us. And we are very pleased to be one of your sponsor or partner as well for this fantastic activity. I have to apologize for my voice. It's one thing when you're pregnant, you cannot take all those medications when you have a cold or a flu, so I have to live with it, but hopefully I'll make through it, no problems. I'm here today to talk about genomics and understanding the possibilities of this great science that has been the talk of the town for the last couple of years. So we'll go through a little bit about the explanation of how it works, how you can use it back at the farm, because that's really the purpose of understanding how it works, and exactly how the industry is evolving with it. So, little words about the science. I'm not going to spend a lot of time on the science side of it, but I think we need to understand a little bit where it's coming from and where do we get this information that we think is so great with this science. So first of all, we work with markers that are equally spaced along the genome. So all human beings, we have a genome, we have genes that are responsible for who we are and how we are physically and what potential we got from our parents. So that's the same for our cows. So we're looking at specific places on this genome to know what should be their potential for the future for traits that we are interested in. But those markers, what are we really talking about here is that we can compare them to those posts that we have beside our highways that indicate us where we are and how many kilometers we are away from our destination. So those are really places on the genome where we look for information, for specific information. And so they are the spots where we verify if the animal is carrying 0, 1, or 2 copies of the gene at that specific location. And how did we find out about these markers? Is that we make connection between the DNA sequence of the reference population, and I'm going to explain what's a reference population, and the data that we have recorded in the previous years on daughters with the help of classification and milk recording. So what's a reference population? We've been looking at the genotypes of proven bulls with very high reliability. All these years that we've accumulated data with classification and milk recording, and that we were able to provide proof. After that, we compared the genotype of these bulls, and we compared their DNA segments between each other for specific markers for the one that had the same qualities or the same strengths. So let's say we had a group of bulls that were very high in their genetic potential for feet and legs. Well, we then compared their DNA to know at which markers something was happening, or at which marker we should look for to know if those sires were great for feet and legs. And we did the same for every trait that we have in our genetic evaluation system. So I'm going to go back a little bit in your genetic knowledge, and probably some of you have heard about genotype, phenotype, and the effect of environment before. But the reason why I want to go a little bit review on this is that I have to say the reason why so many breeders are afraid or scared, I'm not so sure about genomics, is that before genomics, we weren't that used to work with genetic indexes on the female side. If you were looking at the male proof, you were all used to see those numbers to select the sires you wanted to include in your herd selection, in your herd management program. But on the female side, we were more used to work with phenotype, like classification, like how much milk she produces. And now with genomics, we're including those genetic indexes in the whole system. And one of the reasons why we're a little confused, or still confused about it, is that it's still pretty new that we're working with those numbers. So I have to say that even for a cow with the most desirable gene, if you test a cow today or a very young calf, even if she has the most desirable gene, the environment that she is in will affect the way she expresses those genes. So of course the environment still has an effect on what we think is the potential of an animal according to a gene. So usually the genotype is what we don't see on an animal. It's usually what we're trying to predict. It's usually what an animal has received from its ancestor and what it should transmit to its progeny. Being different of the phenotype, where it's usually the physical appearance, what she see, what she scored. Does she have good legs? Is she red or is she black? How is she classified? So you have a couple of examples, like LBI, it's genotype because we calculate this index. There's nothing on the cow that says what's her LPI unless you look at the pedigree, right? And it's the same for genotype, for phenotype, sorry. It's the opposite. You look at the cow, how she looks, how she is, etc. So the genotype, it's always estimated, it's never known completely, and it's always a prediction of what we think is the real potential of this animal. While on the phenotype, well, it depends on the genotype, but as I said earlier, it's influenced by management a lot and environment as well. So each animal will convert its potential in different ways because of this reason. That's very important to remember as we explain what genomics is. And the phenotype, of course, will change over an animal's lifetime. So why do we need to differentiate between genotype and phenotype? Well, if I give you this example of a cow that produces 8,500 kilos of milk in an average management herd versus a cow that produces the same amount of milk in a herd with an excellent management, which one has the best potential, do you think?
First one.
The first one, of course, because she produces, that many kilos of milk with a limited or not an excellent management in the herd, while the other one, with the best conditions she could have, produces the same amount of milk. So I think you get the point of what's the difference between, knowing exactly what the potential is and what she's really doing in real, for real. So the challenge of genetic evaluation is always to remove the management or environmental effect to know more about the real genetic potential, so that if we take two animals with the same potential, but put in a different environment, they will react differently. So therefore, by knowing more about the DNA sequence, it helps us to make the knowledge of genotype more accurate. All right? So knowing more about genomics is helping us to have this section more accurate or more precise in our knowledge. So there's a lot of complicated words or new words when we look at this whole thing. We of course talk about DNA, genotype, genetic indexes, and then we convert it into LPI. We have EBV, parent average, DGVs. So I've put the main abbreviation of those terms. Of course, you'll see them mostly in pedigrees or sire proofs as well. And I'm going to go through the main ones here during my presentation. So how do we include the DNA sequence into this? Because for sure, when we're looking at the genetic indexes, first of all, it's important to understand that genomic is not taking over the whole thing. We are including genomic into what we used to do before. So if we look at the EBV, which is the estimated breeding value, or if you look at the sire proof, here we have the example in the male. When a calf is born, when a male calf is born today, the only information we have is our parent average, right? We know what the sire potential is, the dam potential, and then we add them up and we divide it by 2, that's the parent average. Now, if we test this heifer on genomic, that's one more source of information. We just add this to what we already know, which is the parent average. And then if we wait long enough into these animals, if we've used this young sire, and then we market it, well, later in life, we'll have some progeny information, of course, and that's, where we get more information about the real potential of this animal, but we have to wait quite a significant amount of time to get to know this information. So right at birth, that's where I'm saying genomics is helping us to have more information more rapidly than waiting that usually about 5 years to get the proven information for males. And it's the same for females. I mean, if you have a female calf that was born today, you still have that parent average that you know about. And then if we genotype that calf, well, we just add this to this parent average, and then we try, well, we have a more accurate information for its genetic indexes. And then for females, of course, we have our own performance. So when she calves, we have our classification of milk production that is adding into the blending. And then, of course, when she's old enough, we've got some progeny that is proving of what she's able to transmit to her progeny. So those two graphs or pictures were just to show you that genomic is just adding one more source of information. It does not replace anything in what we used to do before. Now, what's an EBV, or estimated breeding value, and how do we work with it? If you look at the sire proof, any numbers you're looking at for production, fat, protein, or if you look on a pedigree, any genetic indexes, you'll see the proof numbers being estimated breeding value. That's the system we work with in Canada. So if you add genomics to it, you'll have a more accurate number, of course. So what's an EBV is doing is that it defines genetic merit, and half of it will be passed on to its progeny. They are usually expressed in units of measurement for each particular trait, like kilos for production or components. And so they provide a measure of the breeding potential of an animal for some traits. So they will take into account the performance of the known relatives and the relationship between some traits, and of course the heritability, what is due to genetics and not to environment. So when you look at genetic indexes or an estimated breeding value, it's really useful information to select parents of the next generation, or what we want the parents to transmit to the next generation for both male and female. It's not necessarily the animal's own ability to perform. And the best example I can give you to explain this is if you look at the sire proof. If you look at the sire proof, you'll have the information that the proof is, let's say, plus 12 from mammary system. Well, we all know, or at least I hope we all do here, that sires don't have mammary system, of course. So it's their genetic potential to have daughters that will have good mammary system. So it's the same for females, of course, and it's the same for all animals with genetic indexes. Yes, it should be part of the potential of what they should be in real life, but most of it is really aimed to select for them to be good parents of the next generation, or what they will transmit to their progeny. Is that clear?
Yep.
Yes, no? If you have any questions, don't hesitate. Now, we often hear about direct genomic value, or DGVs. So if you test an animal, whether it's a male or a female, it doesn't matter, we receive this information. And that's the calculation of when you look at the DNA, that's really the value of those markers that I was talking first in my presentation. So it's really what's the potential according to DNA only. It's an interesting predictor of genetic merit, but it's not as reliable as the blended proof. And when I'm talking about the blended proof, and when we blend this information with what we used to know before, which was the parent average I was talking about. The weight or the emphasis of DGVs in the blended proof depend of the animal that, or the age of the animal, or where the animal is in its life. It will decrease as we add phenotypic information. So for sires that have 1,000 daughters, well, of course, the DGV will not be as relevant or important in the blended proof, because we have so many daughters to actually say what's the real proof of this sire. But for really young sires or for heifers, well, of course, DGV weight is more important into the blending. So when you receive the report of tested animal, that's the top of the information that we can receive. You see that DGV is here. for every trait that we have. So you always have the blended number and then the DGV, which is only DNA. Sometimes it's good to look at what we used to do before genomics to understand really where it's helping us right now. So if we look at the pathway for sires that were going into AI before genomics, so we would have, at 0 here, it will be, let's say, the date of birth of this male calf that was born. And then the AI would come and they would have already interest in the families because of so many reasons, because of the pedigree, because of the dam performance. And then they will come at the farm. If there would be more than one male calf, they would probably pick them according to what they look like, or pick both just to spread the risk. And then we would have to sample them between the age of 12 and 15 months. We would sell the semen as a young sire. We would have to wait approximately 2.5 years before because we need to allow time for gestation, birth of first daughters. And then these daughters, of course, need the calf. We need to register those information of production and classification, performance. And then, as I said earlier, at the age of 5 years old, we would get his first proof. Okay, so by the time that we have all this information to be able to get a sire's first proof, we need to wait 5 years. Of course, now we still need to wait those 5 years because gestation length hasn't reduced with genomics, and we still need to wait to sell those semen and then wait to get those daughters out in the field. But where it can help is here, right at the start. I mean, even before day 0, even before the birth of the male calf, we can have a genomic test taken on the embryo, or very shortly after birth. So AI units are doing their selection with more information than what they did in the past. So of course, a lot of them are tested to try to get the best of the population. But very few of them are selected after this step of selection, of course, because we're trying to pick the best of the best. We, as I said, still need to wait this 5 years to get the full results of the proof, but at least we can do an earlier selection very, very soon in time. And that's the same for female, back in your barns. I mean, you can still, if you have very elite females, you can still do that selection at the embryo stage if you want to, or very shortly after birth. Most people want to get the information before they're doing their first service because they want to use this information to do the breeding. And then some of them will wait until the animal calf, and then we'll do a second selection after calving with lactation records and classification. So again, it's one more piece of information to get a more accurate selection into your herd. So at the end, genomics will help us to increase the accuracy of our genetic evaluation, and at a very young age, because we can do it so much faster than waiting for those data to be recorded. And because of that, it's speeding up our genetic improvement a lot. Now, reliability, because when we're talking about genomics, we're also talking about the reliability number. What does it change? Well, first of all, the reliability of a genetic index is influenced by a couple of factors, like how many data do we have, how many dollars are being quantified in their performance, how many data are we accumulating. Are their results consistent, or are they different from herd to another? What's the heritability of the trait, and in how many herds do we see those results? So those all affect the reliability, of course. And what it's really telling us, reliability, it indicates us the possibility that the number that we're looking at today, how it can vary in the plus or in the minus as we add more data with time. So if we're looking at reliability of 65 or 70% today, well, let's say in a year or two from now, when we have more information in the pedigree, when we have classification records, when we have lactation records, how much that number can change for any trait, for LPI, for type, for production, whatever traits we're talking about. It's the variation that can happen in this number that reliability help us to understand. It gives us an idea of the risk that we're taking. So of course, with a lower reliable number, we're taking more risk than with a high reliable number. And then allow us to compare between different types of animals, so young sires with proven sires, and heifers with cows. So this table is published after each genetic evaluation run by CDN, and it gives us the average LPI reliability according to some group. So if we look at the heifers that were tested with the low density genotype, which is the more used genotype, we're talking at approximately in average 67% reliable information for LPI. Of course, if we are talking about animals that have more information, like young cows that have a lactation already, well, I'm sorry, I was in the DGV weight column. It's here, the reliability, the numbers are similar. So the heifers are 68% reliable, and the weight on DGV that I was talking about before is 67%, because of course we know less about the animal, but as we know more, like having a first lactation, of course the weight on DGV will decrease because we have more information in the system to know what's a real potential. But the reliability is quite the same. So you have for different groups those numbers, and that is updated after each genetic evaluation proves. Now we also have this table. This looks a little confusing with all those numbers, but I think you'll find it useful to know. So in color we have different groups of animal. In yellow here we have the group of animals like heifers and young calf that were not tested with genomics, so their reliability is approximately 35%. So that's the reliability of when we only know what the parent average is, okay? In the green, we have the level of reliability for young animals that are tested on genomics. So for young heifers or young sires that are tested on genomics. And in blue, we have the reliability for sires that have got their first proof at 90% reliability. So the numbers that we are looking at here is the swing that the number can take with more information adding into the system. So that's exactly what I was referring to before. So if we look at the heifer today that has an LPI, let's say of 2,000 points to make it easy, well, in the future, as we know more about this heifer when she calves, when her index is becoming more reliable, well, that 2,000 points could vary, could swing up to 2,361 points or be reduced by 361 points. That's the swing that the proof can get with the different levels of reliability. And of course, if we have a less reliable number, of course the swing is higher because we have more risk. So you have this information for every trait that we have. You can look this for type, you can look for production, whatever trait is of interest to you, we have the information. So that shows you a little bit what's the risk that you're taking by using different level of reliability. So with genomics, of course, the reliability will do variate, of course, for all traits. We will have an additional accuracy, but of course it reduces the gap between the estimated breeding value and what are the true breeding values. So I've made an example here for LPI and type with the same example of 2,000 points. So the different colors here, you have in black, you have the lower reliable animals, the ones that we only know the parent average, let's say. In red, you have those heifers or young sires that were tested on genomics. And on brown, you have those very or higher reliable animals like the proven sires. So of course, the swing is much smaller for proven animals, but it gives you an idea of the swing it can take in plus or in the minus. It can also stay the same. That's what we don't know about. So it's the possibility of variation, but it could also remain the same. That's the risk. So genomics, unfortunately, is not able right now to say which one's going to be the next Arbrood cow or the next show queen. However, for sure, it can help us to differentiate between the siblings, with the ones that have the most or the least potential in the family. It will improve LPI reliability, as I said, as we have a more accurate selection. And maybe it will lead us to the discovery of new and interesting cow families, because sometimes they just need a little more information to get a more accurate potential. Now, how do we do the test? We have a couple of options. So Holstein Canada is the provider of the genotyping services for dairy cows in the country. First of all, we have the low density, which is the most used panel. We used in the past to talk about the number of markers that we were looking at. We first talked about 3,000 markers and then 6K with 6,000. But because science is always evolving, we now refer to LD for low density, because as we go on, we add more markers. So we still have the 6,000 markers, but with some labs we work with 9,000 or even 10,000 markers. So that's why we now refer to letter instead of the real number of markers. So this is the lower cost testing option for $45. For male or female, it's the same price. We also have a blended package for people that are interested into having more information like genetic diseases or coat color with the same sample. So we call it LD Plus, and it's sold for $60. It's a saving of $90 because it would cost approximately $150 to conduct each test individually for dams, blood, coat color. Now, we used to call it the high density, but now we'll call it the medium density panel. Used to be 50K, now it's more 80K, but it's sold for $135. So this is more useful for sires in the eye units and females that are being contracted, because we get a little more information. And Holstein Canada is providing a $2 sample discount on genotests that are received before 3 months of age for registered Holstein. So it doesn't look like a lot of dollars or a good rebate, but Holstein is trying to make it as cheap as possible for its membership. So we're consistently dealing with the labs that are doing or offering the services to get the cheapest prices possible to offer to its members. We have a program for herds that weren't doing registration before, or when keeping track of their sires or information on the parents. So it's a one-step process for genotyping and doing registration at the same time with animals that we have no information before. So it's available for those herds. It's like a combo, a one-step process. There's a form that is available on the website for sure, and then you can just choose all the options that you want to have with this sample. Now we have different options for sampling. The most popular remains the hair samples. So of course we're looking at the follicle of the hair. It's not about how long is the hair that you provide, it's really we're looking at the follicles. We want to have, that's where the DNA is, on the follicle. So we want to have a good sample of quality. The downside of this one is that you never know how good is your DNA or how good is your sample until it gets to the lab. So visually, sometimes it's hard to see if you have enough follicles. That's why we say approximately 40 hairs. And that's easy. I mean, you just pull out the hair and then you stick it on the form and you send it on the mail. So that's really easy. we have those swabs that are very convenient for very young calves. So you just have to swab into the nasal, and then of course you need to buy those devices, those swabs before, but those are very useful for very young calves. You have to order the sample kits at $5 each. And then we have this new method of collection, which is called a tissue sample unit, which is available since last fall. So it's to collect a tissue sample in the ear. You need to use an applicator and a punch, and you will collect a tissue sample directly from the ear, and that way you are 100% sure to have enough DNA, or that your sample is going to be good enough to get tested. The downside of it is that it's not the same tag than the ones that you use, so it's not, you need to buy another tagger. So obviously one day we'll get there, but for some reason we were not able to have it a one-step process with the tagging system right now. So of course you need to buy them ahead of time too. Now, how do we use the results? So you've taken your samples, you've sent it to us, and then after a couple of weeks you've received the results. So now what do you do with them? So you will receive your results on your web account. Some of you have asked me in the past, I'm still waiting to get my results, I haven't received them. I said, have you looked on your web account? So what's the web account? I was waiting for them in the mail. So unfortunately not, it's not coming out in the mail. It will come on your web account on our website. You have it on 2 different formats. You have it on the individual report on the PDF like this one here. And you also have it on an Excel, which is useful because it can be sortable and you can download it, especially if you want to do a herd selection. So that looks kind of confusing with all those numbers, but the good thing with it is that you can sort the results according to whatever criteria of interest is important to you. So if you want to see what are the best ones for production, what are the best ones for feed legs or for mammary system or whatever, you can just sort them according to this with each column. And then of course with the individual report, you get to see the results for individuals. The good thing with this report is that we can see, so as I said before, you have the DGV, which is the direct genomic value, so that's only DNA. You have the blended proof, so that's for a heifer, that's a result for a heifer. Or genomic parent average, so that's the blended information of DGV with the parent average. You have the reliability that goes with it. The difference between the GPA and the pH, so how much did it change with genomics? So did we gain? Did we knew, how can I say that? So was the potential better before or after genomics? So were we overestimating the result before genetics or underestimating? So is genomic helping us to make it better, or did we have a good idea before? And then we have, of course, the gain in reliability with the addition of genomics. So you have all these columns for every trait. This is actually just half of the report, but you have another section on the bottom with all the specific traits related to type, mainly, and functional traits as well. So how will you use your genotype now? Of course, you will have to, you can do a selection of your elite females, and the definition of elite is different in every herd, for sure. But it will, for sure, it will be a good tool for herd management decision. So you'll be able to compare your results within your herd or within the breed, depending on at the level you're looking at. And it's, of course, it's a good choice. It's a good tool to have a good choice for your next ET donors for embryo transfer, or to differentiate between full sisters that you think are the same visually, but maybe not on their genes, and to put some value on some elite females. So that's the interesting part about genomics. When it was first launched in 2008, it was more used for the elite population, and as we go on, it is, I would say, it's now very much popular into those larger herds that wants to do a selection. So they want to use it as a selection tool to have a more accurate idea of how am I going to select my heifers, because I don't want to do it visually, or because I don't want to look at my records of pedigrees or whatever. So it's a new tool for selection for sure. So of course, if we're talking about sire selection, genomics can help you, of course, because then you can divide your herd into groups to then know where you're going to use those specialty sires, like the ones that have sex semens, like the young sires, where you're going to use them in your herd, and for certain traits, the elite sires as well. And it makes the mating program, so whatever units you're working with, they all have mating programs. Of course, it will make those programs more accurate, because if both sides of the pedigrees, males or females, are tested, well, of course, you have a more accurate information at the end on what should be the best for each female. Now, sometimes breeders are asking me, well, do I need to do a selection at my farm? Of course, it depends on your replacement rate. It depends on how many heifers are available at the farms, by group of age. So we all know that doing a selection at the farm will give you some economic advantage, because some of you don't have enough time, enough money, enough space, enough facilities to raise all your heifers. So it's always good sometimes to sit down and say, I need to do a selection. Where should I start? So now with the young sires, the questions often is should I use only young sires? Well, I'm sorry, the answer to that is it depends, of course. So the young sires have higher proof, yes, because these are younger animals, but they also have lower reliability because we know less about these animals. So you have more risk, but of course you get a chance of faster progress. So that's why we say that you shouldn't put all your eggs in the same basket, meaning that you should spread your risk. If you're interested into some young sires, well, you should use more than one, depending on the number of females you have, but the percentage of young sires to use in your herds depend, of course, of your level of being comfortable with the risk, and also with your herd objectives. I've included some questions I'm frequently asked. Now, when should I expect to receive my results after I've sent the samples? Well, right now, the way it's proceed is that once a month, Hosting Canada sends the samples to a lab. So we are doing business with a couple of labs. And the results of these samples should be published approximately 6 weeks after the submission date of the month. So each first Tuesday of a new month, we get new results published. So depending on when your sample got in our office, it will be included in the next release or the one after. So we have a schedule that is posted on our website as well as on CDN website to help you out with this. But for example, on March 4, the results that will be posted on CDN will be, or on your web account, will be for the samples that were received before January 23 in our office. So results are publicly available on CDN, but as well on your web account for your personal animals that you own. So this is the submission dates, the schedule I was talking about. So you always have the date by which we need to have them in our office, and then the release date on CDN. Now, excuse me, should I use GPA or DGV? That's a very frequent question. The answer to this is in general, it's GPA, because it's the combination of traditional evaluation and DNA as well. It has proved to be the most reliable information. Of course, DGV is interesting because it will tell you if, before knowing about genomics, if it was under or overestimated by the numbers. But for sure, you have more reliability by blending the two. Also, some people are asking or wondering why DGV changes, why DGV number changes when a DNA sequence shouldn't change, because of course you'll all die with the DNA that you were born with, right? So why are these numbers changing? Well, the answer to that is that the reference population of sires is changing. As we have more proven sires, we add those into the reference population, and sometimes, well, we have to adjust the markers according to that. So it's the relationship between the proofs and the DNA sequence that change, not, of course, not the DNA. So it's the interpretation of the DNA that changes, not its real potential. So it's recalculated at every new proof release. And we're not talking about hundreds and hundreds of points of difference, but sometimes, you know, they get to change a little bit because they are updated. If an animal has a DGV lower than its GPA, how does it affect its value? Well, first of all, its value depends on its level within the herd or within the breed. Because for some of you, a specific number could be very, very good, and for another one, it could be just average in this herd. So it means that its GPA was adjusted. If the DGV is lower, well, we just have adjusted what we used to know before. It doesn't mean the animal has more value, we just have a more accurate idea of its real potential. So, of course, it depends on the swing, but in general, we shouldn't say that it affects the value that much. Should you test all your animals? Well, it depends why you want to work with genomics. If you want to use it for selection purposes, if you are doing only random testing, well, you're probably not going to get the result that you want to have, right? So you should work with groups within your herd. If you don't want to do the whole herd, you should perform some group testing, and then, of course, depending where you want to do your selection, you'll work with those groups. But so you can, another way of working, I've seen some large herds doing the average group, so they know that the very high-end groups, they will remain in the herd, and the ones that are at the bottom, they will probably leave the herds anyway. So they test the average group to separate the above and below average animals, just to make sure that each one falls into the right category. One thing that is good to remind to producers with genomics is that you don't need to change your herd objective when you start genotyping. I've had a lot of questions about it, like I don't want to look at genomics, I don't want to do it because I'm a type guy, or I've looked at pedigrees for so long, I don't want to ruin it with genomics. Well, genomics is adding accuracy to the genetic potential, and it's providing you one more source of information, so you shouldn't change it. If type is important to you, well, stick with it, keep looking at it, but you can look at genomics of type, of the type index. It's there. So you use it along with other criteria of interest to you, whether it's cow families, generation of very good or excellent production, whatever. So you don't need to sacrifice your philosophy in order to work with genomics. It's just one more tool available. So we've had some work done in the past about some economic benefits from heifer genotyping in a commercial herd. So depending on your number of course, number of heifer available related to your replacement rate, and the mortality from birth to genotyping. Of course, as we have more heifer to select from, of course, we get a higher benefit to use genomics because we have more. If you have a lower replacement rate, of course, you have more animals available in your heifer population, so the percentage to cull is higher than those that have a very high replacement rate. So this study was done according to different parameters used by Jacques Chenet from CMEX Alliance, and you have them in your slides. You can look at the parameters he used, but we can see that of course there is a economic benefit to use it. And here, according to different percentage to cull, again, you can look at what should be the percentage to genotype in the herd, according to what we know already in the herd. So if we know all the records, or if we have nothing before, And then he did the same with but for herds that were using sex semen on heifers. So of course we have more females, even more females. So the benefit is higher because once again we have more heifers to select from. In the last year, well, since Genomics was launched in 2008, we've gained a lot on the average gain of LPI points per year because of course we're doing a much faster selection, as I was saying first, right at birth or very shortly after birth. So of course we're doing an increase of a lot more gain of LPI per year according to what we used to have in the past. Now, when should you test? Well, you can do it whenever you want. At birth, it's one advantage to have the faster the information. It's the best option if you want to color market very early. Some of you will do it before first service to get the information to do the best readings. And sometimes to have some time in calving for more favorable time of the year for market price as well. And of course, your best young cows should be identified in the first month after calving, and so some, but very few, will test after calving for this reason. And then when you receive the result, of course, it allows you to rank your animals in the herd. Sometimes it will change your herd strategy. As I said, it shouldn't change your objectives, but for some reason, a family will lose point in production, but will increase in herd life, for example, so you will change the evaluation that you're making out of certain families, or you can say, well, I was trying so hard to work with this family, but obviously it doesn't seem to transmit that well, so maybe I should change my focus and now work with this line of family in my herd. So that's the kind of information that you can rely on as well. So this is the whole report for individual animal. As I was saying, you have for confirmation as well for functional traits. Actually, I had 2 reports, and when I have smaller groups, I usually do the comparison between some animals and should this animal be selected or called, so according to different criteria. Now, it's good to know that you have information to do a selection, but you need to know what's the population average for those traits. As I said at the beginning of my presentation, on the female side, we're more used to work with classification. You all know, you all picture in your head, if I'm telling you this heifer was classified 83 points at 26 months of age, you all have a picture in your head, you all know what it's like. But if I'm telling you this heifer has an LPI of 2,800 points, what does it tell you? So it's good to have some benchmarks to compare the LPI levels for females. You have to know that the average in Canada is 1,800 points, and that scale is between 0 and around approximately 3,500s and some plus. So you have different percentile rank here, and then for milk, fat, protein type, and LPI, you have the standards or the benchmark. So that's for females. It does change a little bit for males, but for females for sure. So here, if you look at the average or the 90th percentile, well, you know where you stand with your own results. Like all good things, there are some risks. So we're still at the early age of the science. We still have some gray zones because, of course, it's not 100% reliable yet. We still have to learn a lot of it. And for some reason, we're looking at the reason why some predictions are working better on some families than compared to others. So we're looking at this right now in the research side because for some reason we've seen that. If you're looking on the different results on the international market, you should know that the reliabilities can vary from one country to another, so they're not calculated the same way. So that's why I'm saying it's one risk, because if you look at the international results, you should know this. And of course, some young sires are now sold as proven sires. So yes, the progeny testing is still the ultimate test to have a reliable number. But again, it's a matter of how fast you want to go. In the past, we've put a lot of emphasis on the rankings. So the top animal, this heifer was number 1. And then the next month, or even the next day, I'm sorry, but she's not number 1 anymore because there's a new one that have been tested and that is better. So we should focus really on the potential of the animal. The ranking, well, we'll leave that to some very, very elite breeders that are doing the race for the number 1s. But on average, when you're looking at the numbers, you should look really at the strength and weaknesses of the animals to have an idea of its potential. However, I'm not here to say that it's not a good thing. It's a great advent for genetic improvement overall in our industry, for sure. One thing that is good is that it's not affected by preferential treatment, and the reliability levels will help us to understand the risk. So that's one thing we have to be aware of. From now on, genomic selection will be part of our genetic improvement tools. As I said, it's a tool, so it's one more piece of information into the system. Now about inbreeding, we've learned more about the true inbreeding levels in the breed. Now we still have some learning to do about this, but for sure we'll gain more knowledge as we go on and as more animals are tested. And what's the most interesting, I think, is that it should lead us to new trait or new genetic diseases that we didn't know about before. So by knowing more about the genes of our dairy cows, we will learn more about what can affect our efficiency. So the evaluation will evolve and get better for sure, because we'll have more accurate information as we have more animal tested. The calculation methods are always refined as we have more animal tested. The increasing number of young sires and proven bulls will be used to calculate the SNP effect, so the markers. And because it's less expensive than it used to be when it was first launched, and because we have more testing option, more female will be tested as well. As I was saying, it's going to be interesting for new traits. Maybe in a couple of years from now, we'll be talking about early selection for new traits like reproduction, feed efficiency, milk quality, and all because we learned more about the genes. But first of all, we always need good data to like traditional genetic evaluation, to get those genomic evaluation like we had before with classification and milk reporting. And because of that, milk reporting and classification are still very important. Genomic works overall. Yes, there are some exceptions, but when we're looking at the whole population of animals that were tested in the past, we're doing validation, so we're looking at proven bulls or proven cows, and we're comparing their proof without and with genomics. And we compare their GPA with the GABVs, and yes, overall, the trend is that it works. Again, there are some exceptions, but overall, in the whole population, it's been doing good. Do we still need to classify and register? Absolutely. If we go back to my first slides, I was talking to the difference between genotype and phenotype. Yes, we can have an animal with the best genes. However, again, the environment she's in will affect the way she expresses those genes. So, one of my favorite sentences in this presentation is that you cannot improve what you don't measure. If we don't classify, if we don't milk record, then we have no idea if our predictions were good or not with the genomic predictions. So it allows us to realize if genomic predictions were accurate or are still accurate. And of course, the management, the environment influence the way the genotypes are expressed, and this changes over time. So we still need to record if that proves to be true. And I've been repeating myself a little bit, but yes, it's good genomic, but it's one more tool into the whole picture of what's available to you to take good decision. Using more information results in better decisions, you all know that. So by adding this to your whole system, it should lead you to have more accuracy into your tools and doing or performing a better selection at the end. Some numbers here to finish with. I've included the numbers in 2013 of the numbers of males and females, whether they were done on the low density or high density panels, how many were done by province and total. So here in BC we can see that there's been some samples that were tested, and overall in the country we've increased this number by 41% according to 2012. So people are more and more interested into the science for sure, and yeah, we'll see where it brings us. And of course, as I said, as we test more, we have more animals to see how it's validated in the field. So thank you very much once again. If you have questions, I'll be here for the rest of the day, but if you have some now, I'll be happy to answer them. Yes?
Well, you mentioned earlier on in your presentation that you've gone from the high density to the medium density panel, renamed it, remarketed. Does that mean there's even a better one around the corner? That will be your new high density?
The high density, it's already available. Not really marketable because it's more for, like Goldwyn was tested on this high density. We're talking about 800,000 markers. Like it's more to in the reference population again to prove or to have a more accurate of those sires that have a lot of daughters, and that we wanted to. But on the female side, it will remain the medium density panel that will be the ones that is marketed. So it's the science is allowing it, but on the market it's because it's so much expensive, and the ones that are available right now are very much like for what we need. Yeah, it's the best option we can provide you.
Yeah, thank you.
Any other questions? If not, well, congratulations for being here today. It's
Valerie?
Sorry. Yes.
I just, like, you talked all about the Canadian side as far as genetics, but like on the U.S. side with genomics, is there a difference on how they're using it?
Yes, very good question about the difference between the U.S. and Canadian system on genomics. Yes, there is a difference. The weight or the emphasis on DGV, on direct genomic value, is not the same between the two countries. And as I said, the reliabilities are not calculated the same. So if you look at, or if you work with US numbers, you should know that. The weight or differences, like it's not that clear or how it's different, but for sure they put more emphasis on the DGV than we do. So we are being safer, I would say. We tend to think that we've accumulated a lot of good information in the past with milk recording and classification, and we still think that it's important. We don't want to throw it away. So we are saying DNA is important for sure, but we think that blending the two information together is the most reliable and not putting all the information on the GGV. So yes, it's different. The differences are not that clear, but you have to be aware that it's they're putting more emphasis on DGV than we do. And reliabilities are usually higher. It's not because that their numbers are usually better than us. It's again a question of how they calculate it. So I don't know if it's a Canadian thing, but we always tend to try to be more on the safe side, and try to be try to let the numbers be proved before we put higher numbers on reliabilities. Any other questions? Yes.
How is reliability affected when there's a LPI roll, when there's an index rollback, like when all the numbers get lowered? Does that affect the reliabilities? Because we're saying when you have these higher index animals and their reliability is lower, then it's all scaled back so that their index is closer to that of an older cow, which has it. Does that affect the reliability though, or what is it?
Not really, because the rollback, as we're talking about, is done every year in Canada. like you're trying about the base change that we're doing because our population is, and correct me if I'm wrong if it's not what you're saying, but every year we are doing a base change because our population is evolving, so we are doing a rollback just so that everyone is put on the same scale. So reliability is not really affected by this because the whole population is changing. So it's more a question, again, of what the results that we are seeing and how many results do we have, the consistency of the results, and the heritability of the traits. So, and for DGV, reliability is affected by the markers that we have, that we know in the reference population, as well as in the pedigree, in the actual pedigree of this specific animal, how much do we know? So if we have generation of dams that had very, very high reliable numbers, of course that will affect the reliability of our animal that we're talking about. But the rollback, not that much, no. Other questions? I was going to say congratulations for being here. It shows certainly that you're interested into those topics, and it's fantastic opportunities that the branch is allowing you. So congratulations for coming, and hope you have a great day. If you have questions, I've put my email. I know I'm not down here quite often, but email is good. I'm just a phone call away, or any information you need, we'll always be happy to provide it to you with the Hosting Canada. Have a good day.